Finding the equation of a line that is tangent to a curve at a specific point can be a little bit tricky, but there's a quick and easy method that you can use to find this relatively easily. So today I wanted to show you what that method is so that you know how to find the equation of a tangent line to any given curve at a specific point. So let's go ahead and jump right on into it. So here's the problem we're going to be going over today. We're going to find the equation of the tangent line to the curve at the given point. The curve we're given is y equals the fourth root of x, and the given point is the point 1, 1. So when you're doing these problems where you're trying to find the equation of a tangent line to a curve at a point, you always want to start with the generic form for the equation of a line. We know we're trying to find a tangent line, so obviously that equation should look like a line. Well, the equation of a line is y equals, there's actually a couple different forms that this could take, but generally the easier, kind of more adaptable version is y equals m times x minus x0 plus y0. So this is a line which has slope m, and it goes through the point x0, y0. So basically, there's two pieces that we need to figure out in order to fill in this tangent line equation. We need to find the slope, and we need to find a point that it goes through. Well, we know that a tangent line, it has to have two things in common with your function at a specific point. First of all, it has to go through that point, so it has to share that point in common. So we already know right off the bat that our tangent line needs to go through the point 1, 1, because it needs to be tangent to our curve at that point, which means it needs to go through that point. The other piece that it needs to have in common with our function is it has to have the same slope at that point. So in other words, the slope of this tangent line, the m, is going to be found by figuring out the slope of this curve at this point. Well, if you ever hear slope in calculus, your brain should automatically go to derivative. Derivative is usually going to be the way that you want to find slope of something. So in order to find the slope of this curve at this point, we need to find its derivative. So we need to find y prime. Well, to find y prime, whenever you're finding the derivative of some function with a root, in this case a fourth root, it's usually easiest to first convert that function into a power instead of a root. So what you want to keep in mind is y equals the fourth root of x is exactly the same as saying x to the 1/4 power. Having the something root of another thing is the same as raising that thing to the 1 over whatever that root was. So in other words, if we have y equals the nth root of x, we can rewrite that as x to the 1 over n power. So what that means is what we're actually trying to find the derivative of is x to the 1/4. And the reason why that's nice is because x to the 1/4 can be derived using the power rule. Well, the power rule just says that we want to bring our power down in front. So our 1/4 will go from the power down to the front of our x. And then we're going to have x to the whatever your old power was minus 1. So 1/4 minus 1. Well, 1/4 minus 1 is the same as 1/4 minus 4/4, which is the same as negative 3/4. So therefore, y prime is going to be 1/4 times x to the negative 3/4. So this is our derivative of our function. So now to find the slope at the point 1, 1, all we have to do is plug in that x value, which is given right here, x equals 1, into our derivative, and that's going to tell us the slope of our function at that point when x equals 1. So doing that is going to give us 1/4 times 1 to the negative 3/4. Well, 1 to the negative 3/4 is just 1. And the reason for that is 1 to the negative 3/4 would be the same as 1 over 1 cubed, and then take the fourth root of that. 1 cubed is just 1, the fourth root of 1 is 1, 1 over 1 is just 1. So basically this whole piece right here is just 1, so we get 1/4 times 1, which is just 1/4. So the slope of our tangent line needs to be 1/4, therefore. Because again, the derivative tells us about the slope of our function. Since we plugged in that point, we know its slope is 1/4 at the point that has to go through it and has to have the same slope at that point, by definition of a tangent line. So we can plug in 1/4 for m. And then, like I said, we already know that it goes through the point 1, 1. So we can plug in 1 for x0 and 1 for y0. And then from here, all we really have to do is simplify this. So now we know this line equation right here would be tangent to this curve at the point 1, 1. I hope you found that video helpful. If you did, please be sure to give this video a like, hit that subscribe button down below as well, and hit that bell icon so you're notified of all my new videos. If you want to take tangent line equations a step further and learn how to do these on problems that require the use of implicit differentiation, I have made a couple videos on that as well. Go ahead and click on one of those over there and keep on learning. Thanks, and see you next time.